Hello friends, I'm a cloud solutions architect at Microsoft and my aim is to empower every single person to be better at technical interviews. Keeping with that goal in mind, today we are going to do a very interesting lead code problem called first missing positive. And if we see some of the popular companies who already asked this question, there are companies like Amazon, Microsoft, Google, Apple, IBM, TikTok, Hudson River Trading, ByteDance, Twitch, Facebook, Uber, and Snapchat. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode hard problem and also very well like problem on LeetCode. Basically, we are given an unsorted integer array called nums and we need to return the smallest missing positive integer. So the problem statement is really small and easy to understand. The tricky part in this problem is that we are being asked to solve this problem in big O of n time with a constant extra space. So time complexity has to be big O of n and space complexity has to be big O of 1. So this is the difficult part that we are trying to achieve. Now first let's try to understand this with few examples that what does this problem is asking us to do. So in this case we are given a numbers array and in this case the values are these. Now we are trying to find the first missing positive number. Okay. Now what is the first positive number? First positive number is going to be 1. Then what is the second positive number? It's going to be 2. What would be the next one? It would be 3. Now in this case, since 1 and 2 both are present, 3 is the first missing positive number. So we need to return 3 as the answer. If we take a look at the second example, again in this case we have 1 present, but we do not have 2 present. So because 2 is going to be the first missing positive integer, so in this case we don't even need to check for all the remaining ones. 2 is going to be the answer that we need to return. And same goes with this example. In this case, since we don't even have 1 as the answer, we are definitely going to return 1 as the answer because 1 is the first missing positive number. Okay, so the problem statement is really easy to understand. Now let's see that what could be the possible different approaches we can take in order to solve this problem. Well, the first approach that comes to our mind is a brute force approach. In the brute force approach, what we are going to do is we will try to find the first positive number. So first positive number is going to be 1. We will see that whether 1 is present in this or not. Okay, so 1 is currently present. So now we will move on to 2. 2 is also present. So then we will move on to 3. So value number 3 currently is not present. So we can say that 3 is the first missing positive number and we will return 3 as the answer in this case, right? But the thing is, what is the issue with this brute force approach? Well, the issue is quite simple. Time complexity is actually going to be big O of n square, which is disastrous. So we will have to do something better than this. Let's try to find another approach and see if we can do something better. So say for an example, suppose this is the given input. The idea is that if for this given input, if we somehow sort this input, we would actually able to do something better. So let's just see the sorted result. All we need to do is go to the first positive integer. So in this case, first is 1, 1 is present over here, and then move to all the other elements until we find a place where the next element is missing. So in this case, we can clearly see 3 is missing. So 3 is again going to be the answer for the sorted approach. So sorted approach works better than the brute force solution. But the issue with the sorted approach is that from given input, in order to generate the sorted array, it takes us the time complexity of big O of n log n just to generate this sorted approach, and then we will have to iterate over it once. So the thing is, this time complexity is still more than what we want. So this approach is also not going to work. Let's try to see some better approach. Okay, now before we go to the next approach, first let's try to make things much easier to understand. Suppose if we are given any input and if all the values are starting from 1, only positive values that are incrementing in sequential order, what would happen in this case? What would be the first missing positive in this case? Well, definitely the first missing positive in this case is going to be value number 5. Why value number 5? Because currently the given input n only has 4 characters and all the characters are like 1, 2, 3, 4. So the minimum possibility is that the value could be 5 or it could be any single value from starting from 1 to 4. So basically all the values that are concerned of us is that the first missing positive will only be between the given n plus 1. So from 1 to n plus 1 is the possibility where the first missing positive value lies. In any other values are no use of us. So say for an example, if we are given input n where the values are such as like -1, -6, then +8, then 1, 2. something like this. If this is the possibility, definitely the first missing positive in this case is going to be value number 3. But the thing is, since here there are only 5 values, the first missing positive number can only lie between the values of 1 to 6, nothing more than that. So if that is the case, why are we even concerned with all the values that are not between 1 to 6? If say for an example, values like these 3, we are not concerned with them. And I already explained you why we are not concerned with them, because we are actually going to use it in one of our next approaches. So say for an example, if this is the input we are given, previously for the sorting and also for the brute force, what was the issue happening? The issue was happening that if we want to search that whether value number 1 exists inside this given input or not, it was causing us a lot of time. So what if we speed up this process? We can actually speed up this process by creating a hash map. And what would we do inside this hash map is that at any given position, we will first try to identify whether 1 exists or not. And 1 is not, if 1 is not existent, definitely we are going to return 1 as the first missing positive. That is going to be our answer. That is going to be the most simple case scenario. But if 1 is present, then we are guaranteed that the value of first missing positive is going to be between 2 to 6. So any value that does not lie between the values of 2 and 6, we can simply denote their value as 1 inside our hash map, and then we will do something tricky with our hash map. So let's apply this logic to our hash map. Let me quickly draw the hash map from given input. And by the way, for any particular value, this is going to be the key, and its subsequent value is also going to be same, except for these 3 values where the value is going to be 1. This is the hash map we have been able to generate from our given input n, where the key is the same value as the values inside our array, and its subsequent value we have done some modification, and all the other positive values, they are equal to whatever their subsequent values are. Now all we need to do is, we know that the answer could only be lying between 1 to 6, nothing more than that for the first missing positive. So we will run a loop starting from value number 1 to 6, and we will try to see that whether all the values between, like including 1 and 6, between 1 to 6, are they present inside this hash map or not as key. And we would be able to do this in constant time, because that is one of the property of the hash map, and that is going to make our lives much more easier. So first we will try to see that whether 1 exists inside the hash map or not, and definitely 1 exists over here. So we can simply go to the next element. So we will check whether 2 exists or not. 2 also exists, so we can simply go to the next element and we will check whether 3 exists or not. Since 3 does not exist inside the hash map, we can immediately say that 3 is going to be the answer that we need to return. And this is a very good approach. This solves a lot of our problems that we were facing in terms of time complexity. Why? Because it takes big O of n time to generate this hash map. Okay, so in order to generate the hash map, it takes big O of n time, and then in order to run this loop and to come up with the answer that whether the value exists or not, that also takes big O of n time. So if we see time complexity, basically we have been able to complete this problem in big O of n time, and this is going to be great. This is a wonderful result, and any single interviewer would be more than happy with this approach. But the thing is, in this problem, if we see space complexity, this is where the problem lies for this approach, because space complexity in this case is also going to be big O of n. Why? Because we are creating an additional hash map. Meanwhile, we are explicitly told that we need to complete this in big O of 1. So can we do that? And the answer is yes. Okay, now let's see that what would be the optimal solution where we also do constant space complexity in order to solve this problem. The logic we are going to keep are same, that any values that are too great or negative or 0, we are actually going to convert them to 1. Now let's see that in this given input, how many elements we are given. We are total given 8 elements, which means that the answer has to lie between 1 to 9 for the first missing positive integer, which means any value that does not fall in this range, we will actually have to change it to value number 1 inside this given input. So let me create a new array. This is the new array we generated. Now let's do a quick recap. Basically, we first check that whether 1 is present or not. Since 1 is already present, we iterated over this given input array, and from that we converted this for all the values that were not falling between the values 1 to 9. Okay, now we are going to do things a little bit interesting way. what we are going to do is, since we already know that 1 is present, which means we are not worried about value number 1, we are simply going to iterate over this values whenever we find a value that is not 1. A value that is not 1, which means, say for an example, we find this value number 5. So we will go to its subsequent index. So in this case, we will go to index number 5, and whatever the value is, we will just convert it into negative. Nothing more than that. This is a very simple approach. So let's just quickly do another array, and we will follow the methodology I mentioned. In this case, the first value is 5. So because first value is 5, we will try to find subsequent value and convert it into negative. So this becomes -3. This is value number 1. So we don't need to do anything. Again 1, again 1, and again 1. So since these 4 are 1, we are not going to do anything. Now this value is -3. So because this value is -3, we will go to third index, because this used to be a +3 value. And remember what I said, anything but 1. So in this case, we will go to this value and convert it into negative as well. So this becomes -1. Now we are okay. Again, this value is 1, so we don't need to do anything. This value is +2, which means we will go to second index and convert it into negative. Awesome. Now, what are the things we have been able to dictate? We already know that 1 is present, which means that the answer has to lie between the values 2 to 9. Now in this case, since we will start iterating over from value number 2 to all the values remaining inside the given input array, because we already know that 1 is present, so we don't need to do anything. And now all we need to do is to check that whether that value is negative or not. And the moment we find the first positive value, that index value is what is going to be the first missing positive integer. Yes, this is the whole logic. Now in this case, since this is -1, this is -1. So these two values, we have been able to dictate that why they have been turned into -1, because their subsequent values were present at some point inside the given input array. That is why we converted them to -1. So we can ignore these two. For this particular value number 4, this is a positive value. The moment we identify a positive value, this can only remain positive if there was 4 nowhere to find in this given input. Say for example, we found that this value was 4, then we would have definitely converted this to -1. But the thing is, we did not find anything, and that's why we left it as positive, and we have not been able to find 4 as the first missing positive. So we need to return 4 as the answer. And this is the optimal solution. If we see time and space complexity, in this case, the time complexity is actually going to be big O of n. Why? Because first of all, it takes big O of n time to generate this, and then it takes big O of n time to find the first missing positive integer. So we are satisfying on that aspect. And if we see space complexity, well, apart from using couple of variables, we are not using any additional space, because all of these things are being done on the given input array nums. We are not creating an additional new array. This is a very good time and space complexity and a great approach to solve this problem. Because if you see in this problem, what are all the things we have been through? We first saw the brute force solution, then we saw the sorting solution, then we saw a hash map solution, and then we saw the optimal solution. So we actually went through 4 different approaches, and every single time we started to improve upon something. And this is what any single interviewer would want to see, that how you have been able to do things. And that is why FAANG companies love asking this question. So now let's move on to the coding. So for the given input, first we are going to check that whether 1 is present or not. If 1 is not present, we are simply going to return 1 as the answer. Okay. Now the logic we are going to apply is that any single value that is not falling between our given range, we are going to convert it to value number 1 inside the given nums array. Now all we need to do is we will need to go over the given input array where we have already changed the values with 1, and anytime we identify the value is different than 1, we will go to this array and change its subsequent index location to a negative value. Okay. Perfect. So now with this loop, we have been able to convert all the values to the negative value wherever we find a subsequent positive value, any value apart from 1. Okay, now all we need to do is run a for loop from int I is equal to 1 to the last element, and we simply need to check that at any given position, if we identify a positive value, we are simply going to return that index character, and that is going to be the answer. Now we are also going to check for a couple of edge cases as well. Somehow if we are not able to return the answer, which means we have found the perfect sequence, so we will need to return the last value inside our first missing positive integer, which is going to be n plus 1. And this is the whole code. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions, which means this is a great solution. And I will be posting this in the comments, so you can check it out from there. Thank you.